What's up, guys? So here we are back, chapter 3, cycles of the sun and moon. In chapter 2, we learned to take a look at the sky using this celestial sphere model, and how we saw the apparent motions of the celestial bodies as a result of the Earth's daily rotation. All right, on its axis, it rotates every day, and then this wobble that we have, what we call precession, and we saw that as a 26,000 year cycle of what star is the North Star, where it's pointing. Talked about how astronomers divided the sky into 88 different constellations. Remember, constellations aren't always just the way that we connect the dots in the sky to make pretty pictures. They represent sections of the sky, and they don't include all the stars that we can see. All right, but they separate the sky. We learned how astronomers to classify brightness of stars using a magnitude scale. Larger magnitude of star means it's dimmer as seen from Earth. We talked about flux. The light energy that hits 1 square meter of the sky per second. And this is a really rigorous scientific definition that we need new technology and scientific measurement devices to measure. What you see in the sky depends on where you are on the Earth. We're going to kind of take that and flip that up a little bit with this one. We're going to see how the sun, moon, and the planets move against this background of the sky and how that affects us and what we see here on Earth. So to us here on Earth, Earth's orbit around the sun makes sense, and makes sense as though the sun is moving in motion against the backdrop of the stars. So imagine the sky as a screen, and the shadow of the Earth's orbit is the ecliptic. Right, that's what this little path is that you see on the screen. So this elliptical path that the Earth follows around on its orbit, it traces this out along the sky, and we see that. It's the apparent path of the sun against the stars. So if we flip that, what we see. So know that the sun doesn't move, we move around the sun. But from the reference point of the Earth, it looks like the sun is moving, rises in the east, sets in the west. As the sun seems to move across different constellations, like Aquarius, we say the sun is in Aquarius. So if you notice here, like Aquarius, from the Earth here, if you viewed out to the sun, we see Aquarius. This is where we get this the zodiac signs. If you're in Aquarius, for example, that means the sun is in Aquarius when you were born. It's not that the sky you can see in the night sky, you can't see Aquarius. So a lot of people think that that's what it is, right? These Scorpio, Libra, Virgo, Leo, Cancer, Gemini, Taurus, Aries, Pisces, Capricorn, Aquarius. All of those zodiac signs are constellations, and they are kind of evenly spaced, as you see this picture, evenly spaced around the orbit of the Earth, or around the sky, as we orbit around the sun. The sun is in Aquarius means it's kind of the opposite. Like we don't see in March, we don't see the constellation Aquarius, that section of the sky, but you see it during the day. Zodiac signs are based on that, and it's kind of like a practice that just it doesn't have any power over your life. It doesn't mean anything about your personality. It's total nonsense in that respect. Astrology is practiced. It's a cool thing to think about. It's not science. Science is based on evidence, and astrology is based on superstition and some just disregarding evidence. They don't even take that into account. So it's fun to think about, but it's not science. The Earth takes 365.25 days to complete a cycle, which means the sun travels about 1 degree eastward in 24 hours. Even though we don't really notice this apparent motion, it's so bright it obscures the background of the stars, but it does move a little bit. The seasons of the sun are due to the Earth's tipped axis of rotation. We talked about this already a little bit. Here you can kind of see a visual of what that looks like. I'm going to do a demo in class with a flashlight and kind of show you some stuff like that when I get back to you guys, or I'll just make that video and post it separately. The axis of rotation is tipped 23 degrees, and this is why we get different amount of sunlight in the sky or on the Earth because of this apparent motion as it moves around. As we rotate around the sun hits the Earth at a different angle, depending on the time of year. All right, winter hits us in the northern hemisphere less of an angle. Cycle of the seasons, we've talked about these. We went through the autumnal equinox back in September. The winter solstice is approaching. give or take a day or two due to leap years and daylight savings and stuff like that. But generally, these are the dates, and they remain the dates through the whole time. Vernal comes from the word green. If you know Spanish, verde, and other Latin languages, it's the similar word. Solstice means sun. So the sun, the solstice meaning it's directly in line with the earth. The seasons depend on the changes due to solar energy, the amount of solar energy. This is what I was talking about kind of with that flashlight that you're going to see that demo I'm going to do later. But if I shine a flashlight, it only has so much light, just like the sun only has so much light. If I shine that flashlight on the table on a direct kind of angle, like the summer solstice light directly on there, see, it's all focused on one area. So all that light and all that energy, all that heat is also hitting there on that one spot. During the winter, it fans out, it spreads out. So it's the same amount of light coming from the same object, the flashlight or the sun, and it's just spread out over a bigger area. So it's less solar energy. This is why we have seasons. It's due to the amount of solar energy. As you can see, sunlight, and at the equator, it doesn't vary that much. It stays mostly the same, or mostly straight on the entire time. The sun spends more time in the sky in the summer than in the winter. Our days are getting shorter. That's what's happening right now. It is October. We're losing daylight every day. I just looked. I play disc golf on Monday nights, and we start, in the evening. It got sunset was 7 o'clock this past Monday. It's supposed to be 7:08. It's supposed to be like 6:48 or something. It's a whole no, that's 6:48. 6:58. It's a whole 10 to 12 minutes different each week, moving here on out, and it changes a little bit. As you can see, the way that happens, the mechanics of that, as the sun travels this longer path in the sky during the summer and travels this shorter path from east to west horizon during the winter. So we get less during the day, less sun. Less light energy means less heat. This is why it cools down so much in the winter and fall. So part of what I want you to think about as we'll let you go here, the Earth's orbit is not perfectly circular. Instead, it's elliptical, which means that part of the year, the distance between the Earth and the sun is less than at other times. So sometimes we are closer to the Earth. Sometimes we are, closer to the sun. Sometimes we are further from the sun. Its orbit is not a perfect circle. It is more of an ellipse. So how can we be sure, I want you to think about this, how can we be sure it isn't the relative distance that causes the seasons, and more so the light incident on the Earth? So think about how you know for sure in your head that it is what I'm telling you. It is the light energy that's hitting the Earth, and it's not the distance to and from the sun. Think about some things that we've already talked about. I'll catch you guys later.